right, now it's time for part 2, subtracting decimals. As we said in part 1, and if you haven't seen part 1 yet, I really do recommend you watch it. Place value is the most important part of adding and subtracting decimals. The decimals need to line up so that the place values line up. So, as we look at this, we're going to start looking at subtracting decimals now. And as you can see in the first example at the top there, we have lined up our decimal. We have the tenths place, the 6 and the 7 are lined up. The decimal is lined up, and it will eventually be brought straight down. The ones place is lined up, and there is no number in the tens place here. And much like if I were adding subtracting 176 minus 27, the 17 and 6 tenths minus 2 and 7 tenths, any borrowing I need to do or regrouping I can do as I move across. And you can ignore the decimal for that part of it, which we'll show here in this one, actually, this problem right here. So I'm going to start just like I would normal subtraction. I'm going to start on the smallest place value, which is the tenths place here, the 6 and the 7. But we cannot subtract 6 minus 7. That's just not doable. If I have 6 of an object, I can't take 7 away from myself. So 6 is not enough. I need to somehow transfer some value to that 6 to make it capable of subtracting 7 from it. And the only place near the 6 that has value I can borrow from is the 7, which is a whole number 7. So really, if we think of it as a whole number in tenths anyways, what we're really saying is I'm going to take 10 tenths, or 1, away from that 7. And that goes back again to the fractions we've been working with. So there's this constant connect between decimals and fractions. They're essentially the same thing. It's just different ways of showing the same thing. 10 tenths has a value of 1 as a fraction. So just like I would normally if there were no decimal here, I'm going to my neighbor, to my larger place value just to my left, and I'm going to borrow 10 from it, which sounds huge, but in truth, you're really only taking 1 away from it. When I borrow from that 7, when I regroup from it, I'm really going to make it a 6. I'm only taking 1 away from it. But when I take that 1 away, the number to the right is going to gain not 1, but that full 10 that other value had above it. Because remember, when you move across place values, you're increasing by a multiple of 10. So I have my tenths place, which is going to jump to my ones place, and that's a difference of 10. It takes 10 tenths to get 1. So that 6 that I am borrowing for is going to actually gain a value of 10. So it's not going to be 6 anymore, and I'm hoping you can see this here, and I keep losing track of my camera. There we go. It's not really going to be a 6, but instead I've brought a value of 10 over. There was 6 already there, and now it is a value of 16. So essentially, I've taken a place value with only, remember we said it could only have 1 digit, and for a very short time, without changing the true value of that 17 and 6 tenths, I have just transferred some of that value to a different place value. And now I can use that value to subtract the amount I need to subtract for it. I'm looking for a difference, and remember again, a difference is the answer to a subtraction problem. So I now have 16 minus 7. Well, 16 minus 7 is 9. If I end up with a number larger than 9, I did something wrong. Because remember, I need 1 digit in that place value when I get done. And so if I end up with more than 9, I did something wrong. So 16 minus 7 is 9. Now, I look now at my number to the left. That's 6 minus 2. Well, 6 minus 2 is 4. And you're going to notice I ignored the decimal right now. I just want to get my subtracting done. That decimal has to come down at the end, though. I can't leave it alone, or I'm going to get an answer that really doesn't make sense. Finally, I have that 1 minus, well, there's nothing there, and if there's nothing there, that, again, in the last video we said, that means there's a value of 0 there, and 1 minus 0 is 1. Now, here's the problem. This is a number sense issue. This is something I've been really working with the kids this year on. that when you are subtracting or adding or multiplying or dividing, you need to be looking and saying, does my answer make sense with what I'm trying to do? I'm subtracting here. I started with a value of only 17. If I round 17 and 6/10, the whole number, it's really only worth about 17 or 18. How in the world did I end up with an answer of 149 when I'm subtracting from that? And it's a common sense thing that I really want to try to get across to the kids this year, that you really need to pay attention to your answers. Always ask yourself, does this make sense? And if it doesn't make sense, usually that means there's something wrong, and you need to look at, maybe I made a subtraction error, maybe I borrowed incorrectly or regrouped, or in this case, I made a decimal error. I forgot to bring down my decimal. And with adding and subtracting, remember, it comes straight down. So 17 and 6/10 minus 2 and 7/10 is 14 and 9/10. Now if I think about it, 17 and 6/10 is about 17. 2 and 7/10 is really about 2. 17 minus 2 is about 15, and 14 and 9/10 is very close to 15. So this answer makes a lot more sense. I always tell the kids the story of the time I was at a local store and the power went out, and the cashier had very little experience with working with money when the register wasn't working. And he was standing in line, and there were errors being made to the people in front of me constantly. She was misfiguring their tax, and where an item might have been $7, $8, she was trying to charge them almost that amount plus some in tax, almost doubling what they really owed. And I myself, I tell the kids, I said, I got to get out of line. This lady's going to break me. So it is very important that we have that number sense to look at numbers and say, does this really make sense? And if it really doesn't, then I've done something wrong and I need to go back and check my work. And checking our work is so important. Now with subtraction, one easy way to check our work is to take that answer, 14 and 9/10, and actually just reverse the problem. Take this, add the 2 and 7/10 back in, and I should come up with 17 and 6/10. If I don't, that tells me right away I've done something wrong, and I really need to redo the problem, find out what's wrong. All right, let's look at something that will come up sometimes with subtracting. And this has come up already with the kids and some things we've already practiced. That first number is 14 and 3/10, which is larger than 2 and 72/100. I know they have the same number of numbers, and the one starts with a 2, but if we look at our whole numbers, 14 is much greater than 2. So as far as the subtraction problem, this is very acceptable. What throws the kids, though, is the fact that that 2 does not have a number over it to subtract from. And this goes back to what I mentioned in the first video. Decimals are really fractions, and fractions, you can find equivalent fractions. And just like you can find equivalent fractions, you can also find equivalent decimals. One way to think of that is, let's think of 3/10 as a fraction. So, I taught the kids a little rap. When we're changing from fractions to decimals back, we say it, we write it, and then we reduce it. And we kind of did it to a say it, write it, reduce it. And I can't take credit for that. I found that on YouTube, and the lady who shared it, I'd love to give her credit, but I haven't been able to find it since. But not mine, but a great way for the kids to remember how to write these fractions from the decimals. So when we say 3/10 as a fraction, we would write it 3/10. Now, the problem is I need something in the hundreds place, because the hundreds place is where I have the missing value. So the question is then, what do I multiply that denominator 10 by in order to make it into 100, or can I even? If I can, then I'm finding an equivalent fraction. Well, 10 times 10 is 100, and that's the beauty of working with decimals. They're all multiples of 10, and you can, as long as you're working with tens, you can do this. So anything I do to the denominator, I must do to the numerator, because if we think back to our fraction videos, when I cut an object up into 100 pieces, I didn't just cut up the pieces I wasn't using, I also cut up the pieces I was using. The numerator and the denominator again. And of course, 30/100ths is an equivalent fraction to 3/10. Well, that being the case, that allows me to put a 0 in after the end of my decimal. So in the case of 14 3/10, 14 30/100 has the same value. It's an equivalent fraction being written as an equivalent decimal, if you will. Now I have what I think the kids are more comfortable with. I have a problem where the top number has the end has the same number of digits as the bottom number. Every digit in the bottom number, the number that's being subtracted, every digit has a number above it to subtract from. And I think the kids are more comfortable with that scenario. So now that I have that 0 there, and I want to point out, in a calculator, it's going to drop those zeros. They automatically do it. The zeros won't stay there. And the kids are aware of this. We've looked at that and talked about it. But you can also put the zeros back in on the end. Now, you cannot stick them in at the beginning because that changes the values. It pushes numbers across the place values. But by putting zeros on the end, it's just like multiplying by 10 or 100 or 1,000. And when you do that, you're essentially just adding zeros on the end. When I multiply by 10, I'm adding 1 0. When I multiply by 100, I'm adding 2 zeros. 1,000, I'm adding 3 zeros, and so on. So now let's do the subtraction. 0 minus 2. Can't do it, so I need to borrow from the 3. The 3/10 becomes 2/10, and the 0/100, because there's no value, it's just bringing the 10 over, becomes 10/100. 10 minus 2 is 8. 2 minus 7 I can't do, so now I'm going to borrow from my 4, which then gives my 2 a value of 12. 12 minus 7 is 5. Bring down my decimal. 3 minus 2 is 1. And 1 minus 0 is 1. So I get a value of 11 58/100. Okay? All right. Well, hopefully that'll help some. And I see I'm running over time, so hopefully we won't have to cut this too much. You all have a great evening.